So there will be one question on day 11 there tomorrow. All right, can you guys help me out with the first question I've asked there, which is, can you guys find the sine ratio coming from angle A? What's the sine ratio coming from angle A in this problem? So yes, I'd like you to use y, z, or x in your ratio, please. Use y, z, or nx. Not all of them, but. So what's the sine ratio coming from angle A? And if anybody, let me just remind you of Matt's question a couple days ago. I will have sheets of paper over SOHCAHTOA, so it is up to you to spell it correctly if you're going to use it tomorrow. All right, what's my sine ratio coming from angle A here? Coming from angle A. Let's start this off right. Aiden, what do you got? Yes, y over z. Good. Opposite over hypotenuse. Y over z. Okay, now I have a little bit more challenging question. So if you want to talk about it with people in your group, feel free. Is give me something else. Now I've used this term trigonometric function. What that means is give me another sine, cosine, or tangent coming from an angle that also equals y over z. All right, so sine of this angle, cosine of this angle, tangent of this angle is also equal to y over z. So find another one that's equal to y over z. So give me something else that also has a ratio of y over z, if you had me find it. All right, can you find me another function that also comes out to be y over z? If you have me do it there, where are we going here? Josh, good talk. Amy, how about you?
Cosine C.
Cosine C, excellent. So if I did the cosine of C adjacent over hypotenuse, I would also get y over z. So here's what you guys just showed me in the first two parts, that the sine ratio for angle A is the exact same as the cosine ratio coming from angle C. Those two ratios are equal, which is true. Now I want you to dig even deeper. What relationship is there between A and C? Angle A and C, what relationship do they have? And they're not congruent, so get that out of your mind. Okay, what relationship? And I'm looking for something specific, but I'll take anything from it. All right. What relationship do angle A and C have with each other? Ian, think you got something?
Complementary.
What's that mean again? They do they? Right? I take angle B away, and if they have to add up to 180, all three, what's A and C have to equal? 90. Everyone agree? 90? Yeah, that's exactly what I was looking for. What's so special between angle A and C? They are complementary. And this is the big thing I want you to, we're not going to give tangent any love today, unfortunately. We're going to stick with sine and cosine. Here's the big piece I want you to understand today. If the sine and cosine ratios are going to be equal, they will only be equal if and only if the angles add to 90. Sine and cosine ratios only equal if the angles add to 90. Let me write down the conclusion, then I'm going to put it right in front of your face using the calculator. So here's our conclusion. If, and I'll stick with the same angles we just used up here. If angle A and angle C are complementary, and again, I could substitute in any letter for A and C. Angle X and angle Y, angle B and angle D. I could substitute in any letter. If they are complementary, the sine ratio of angle A equals, am I going to finish this? Whoops, sorry. I got to put the angle name in, huh? Of angle A equals the cosine ratio of angle C. always. But the angles have to be complementary. All right, they add to something else other than 90. Those ratios will never be equal. And can you make a little note too? Know that you can switch these. All right, I could say the cosine of one equals the sine of the other. All right, so these can be switched as far as the word sine and cosine go. All right, it's one thing to write it down. It's another thing to see it right in your face in action. Grab your calculators. Grab your calcs. Make sure they're in degree mode. Make sure they're in degree mode. Make sure mentally you are in beast mode. And I'd like you to type in the sine of 30 for me, please. Sine of 30. The sine of 30, as we see, is 1/2. Tell me something else based on what we just talked about. What else could I just type in the calculator that will also give me an answer of 1/2? And don't tell me to type in sine of 30 again. What else could I type in the calculator that would give me 1/2 again? Charlie, you got it? Try it out, everyone. Why? Hey, first of all, why'd you pick 60? I could have picked any, you could have picked any angle. Why 60? Yeah, you know if sine and cosine are going to be equal, those angles have to add to 90. And look at that. Look at that. 1/2, 1/2. Oh, I'm not done. Here we go. Let's do cosine of 10. Cosine of 10. Oh, look at that sloppy thing. Look at that decimal. Can you tell me something else I could type in and also get 0.984807753? What else could I type in? Sine, not cosine or tangent. Sine of 80. And why 80? These two are complementary. That's the only time the sine and cosine ratios are going to be equal. Only time. All right, we good? So again, I'm going to sound like a broken record today because that's the only way I can get my point across. If the sine and cosine ratios are equal, their angles add to 90. If angles add to 90, the ratios are equal. Okay, let's test this out now. Let's test this out. Okay, cosine of 20. Here are my directions again. Write an equivalent trigonometric function, which means sine, cosine, tangent, that are going to be equal. Okay, so cosine of 20 is going to have the same value as, let's go to the calcs now with you guys, or the numbers with you guys. Oh, there we go, number 1. Charlie, same as sine 70. Why do you pick 70? The ratios are only equal if the angles add to 90. All right, what about sine of 37? That would be the same as 1/4. Gianna? Good. Again, we picked 53 because it's complementary to 37. Always equal. Just as long as the angles are complementary. All right, do we really understand this? Because now I'm kind of flipping the conclusion on you now. Look at number 3. X and x plus 20. Everyone, those are two angles. They're both acute. What am I telling you? The sine of one angle is equal to the cosine ratio of the other. So how can I find x? And I get it right away. This is what everybody wants to do. You don't understand what I put down on the previous page then. All right, if you're throwing that down. X equals x plus 20. Watch. When are sine and cosine equal to each other? When are those two ratios equal? If the angles are what? If they are, the only time this happens, the sine and cosine ratios are equal, is if the angles have to be what? I didn't mean to do that. Do a different color. There it is. That's the only time. Only time. All right. If you see the sine ratio and cosine ratio equal, you're like, whoa, angles got to add up to 90. All right. Angles got to add up to 90. So that's where that equation comes from to solve. 2x plus 20 equals 90. What do we got? 2x equals 70. X equals 35. If I actually wanted to know what the angles were, we substitute in. One angle's 35. The other one's got to be 55. All right. How are we doing here with this concept? Because usually number 4 today, I've taught this 3 times already, and number 4 just throws people off. I think I got you. I think I got you. And then we do number 4, and it's like, boom, pure chaos ensues. All right, let's see if I got you or not. We got triangle ABC. All right, C's the right angle. If you want to see a visual, sure. C's the right angle, so A and B is the hypotenuse. The cosine of angle A, that ratio is radical 21 over 5. That's the ratio for cosine of A. I want to know what's the ratio for sine of B, knowing that. Let's see if I got you guys hooked or not. All right, first thing I want to know, based on my diagram, what do you know about the angles A and B? What do I know about my angles A and B? Everyone agrees they add up to 90. So if the angles add to 90, what do you know about the cosine and sine ratios? They have to be equal to each other. Is everyone seeing this? The angles add to 90, so that means the cosine of one is equal to the sine of the other angle. Right? If the angles add to 90, the ratios are equal, not the angles. The angles add to 90, the ratios are equal. So does this make this a pretty quick problem? What's sine of B have to be equal to then? Radical 21 over 5. If the angles add to 90, the ratios are equal. So that's how I know they have the same ratio. Radical 21 over 5. How are we doing, all right? Any questions? Try the next one on your own. See what you can do there. See which other one has a ratio of 5 over 13. Same diagram as number 4. So cosine B is equal to 5/13. What else has a ratio of 5/13? All right, what thoughts here? Kissinger, what do you have?
Sine A.
Sine A, good. Because A and B add to 90, the ratios are equal. The sine and cosine ratios are equal. All right, do we really understand it? Let's look at 6 now. Sine of 40 minus x equals cosine of 30x. If you are setting them equal, we're not picking it up yet. You got, hey, say to yourself, oh, wait, they're setting the sine ratio and cosine ratio equal to each other. When is the only time that is true? What do you got to know about the angles if that's true, Aiden? They're complementary. So don't set them equal. Show me they're complementary. 40 minus x and my other angle, 3x, have to be complementary. Add to 90. That's the only time the sine and cosine ratios are equal. Angles add to 90. What are we looking at that? 2x plus 40 equals 90. 2x equals 50. X equals 25. We doing all right? All right, don't make it collapse on me now when we do this last problem. Don't let it collapse. If the angles add to 90, the ratios are equal. If the ratios are equal, the angles add to 90. All right, don't make it collapse. Come on, you're better than that. And I want to feel good about myself too, that this is the 4th go around. I've actually taught this correctly here. If the sine of A is increasing, what's happening to the cosine of B? Okay, ready? Angle, let's start with angle A and B. What do you know about them? Angles A and B, what do you know about them? They're complementary. So what do you know about the ratios we're comparing? What do you know about the ratio of sine A and the ratio of cosine B? What do you know about those two ratios? They're equal, right? Because if the angles add to 90, the ratios are equal. Now let's go to the question. If this is increasing and they're equal to each other, you just told me they're equal. If that sine of A is increasing, what's got to be happening to the cosine of B? It is increasing as well. We got that? Yes. A lot of people told me decreasing in period 3. And I said, all right, well, if that's increasing and that's decreasing, aren't they going to have different values? But you told me at the beginning they should be equal. So you better match it. So it's increasing. This old Regents question too. Increasing, explain why? Well, because, there you go, sine A equals cosine B. So if you increase sine A and they're equal, you got to increase sine B so they're still equal. Here's what I want for the rest of the class, please. You finish the assignment, which you should. You go right to checking your answers to Delta Math. There's the process today. Do the packet work for homework, check it on Google Classroom, Delta Math. All right, and the Delta Math covers everything that's on the quiz, everything.